Hi, this is Amara God, and this is my project video. While I describe my prototype, the background video is just showing you what my prototype looks like. The idea for my prototype was to create a scaled down version of the actual trap. The trap is a wooden box that has one side open for the zombie to walk into. Once the zombie enters the box, it will trip the photoresistor to indicate the zombie has entered, causing the box to close. Then, in the inside, lights and noise will turn on to pop the zombie. Once a zombie is popped, the box will open again, setting the trap for the next zombie to walk into. Now that we know what the prototype is supposed to do, I will show it in action. For the sake of demonstration, I am using a square battery to represent the zombie. I will use a battery to trip the sensor, activating the trap. In the following video, I disabled the motor closing the door so we can see what is happening on the inside. Now that we see the trap is working, I will take you to a video that is showing the actual components of the prototype in detail. The proto board contains 5 LEDs, a piezo speaker, a photoresistor, and a MOSFET connected to the motor. The 4 LEDs go through a resistor and get their power from a digital pin on the Arduino. The piezo speaker also goes through a resistor and gets its power from a digital pin on the Arduino. This LED is always on. The photoresistor is also always on and is connected to an analog pin as an input. I am showing the box to see the cutouts used to put the LEDs and other stuff through. The Arduino is then powered by a battery supply and the program is pre-programmed onto it. For the program, we start by defining the pin numbers each component will correspond to. In the setup, the only thing to note is that the photoresistor is set as an input pin. Now looking at the main code, we start off by reading the value of the photoresistor. Once the value falls below a threshold of 5, we get into the part of the code that activates the trap. This starts off by activating the motor to close the side. Then the LEDs and speakers are turned on for a certain amount of time. Finally, once that is finished, the motor will activate again, opening the side, getting it ready for more use. For this last section of the video, the background video is showing the trap being activated over and over to show that it works properly for more than just one zombie. While the video is playing, I will talk about some of the obstacles that I had to overcome. One major obstacle was the lack of materials I had available. As a result, I had to use spare parts lying around the house. For example, I did not have much wiring left, so I had to cut the cable short on the back of the proto board, which ended up not letting me get enough room to also attach the Arduino to one of the box's side. As a result, I had to leave the power supply and Arduino on the ground. Another obstacle was that I needed to figure out a way to have the photoresistor read a constant value of light at all times unless something walks past it. So in order to combat this issue, I added an LED across from it, providing it a light source at all times unless something walked in between them. This helped me achieve getting the correct functionality of the photoresistor. Furthermore, one thing that I never used before was the piezo speaker. I had never used this before and had to learn quickly on how to use it for my implementation. Aside from some of the obstacles involved in this project, I was required to use my previously learned skills in class and quickly learn new skills to create this functional prototype. Thank you for watching.